Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 8 Kinematics in a Straight Line, Long Question Example 4. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A particle moves in a straight line. Its velocity t seconds after it has passed through a fixed point O is given by v is equals to q plus in a bracket 3q minus 5 close bracket t minus pt square, where p and q are constants. The velocity of the particle is a maximum when t is equals to 13/10 and the acceleration of the particle is negative 7 meter per second square when t is equals to 2. So the question asks to find the value of p and of q. Find the value of t when the particle reverses its direction, hence find the total distance travelled by the particle in the first 4 seconds. Okay, so this is for the question part B. For the question part C, find the range of values of t when the particle travels due west. Okay, so take a note at this caption. Take the motion due east as the positive direction. Okay, so this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries, I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. For the question part A, we are required to find the value of P and of Q. Okay, so one thing you need to know, when the moment you see two variables in a question, you need to come up with two types of equations. Okay, before coming up with two types of equations, find for two important informations that you can possibly convert to two equations. Okay, so the informations are in the question here, so you need to gather it. So the first information that you can possibly convert to equation is the velocity of the particle is a maximum when t is equals to 13/10. So this will be the first information, and the second information is the acceleration of the particle is negative 7 meter per second square when t is equals to 2. Okay, so this is the two information that you need to convert to equation, and that equation will lead you to the solution where you will able to find the value of p and of q. So this is the overall idea on how we're going to solve the question part A. So let us begin our working now. Okay, so let me write the velocity equation given by the question, where v is equals to q plus with in a bracket 3q minus 5 close bracket t minus pt square. Okay, like I mentioned, this is the first information. Okay, so let me write it over here. When t is equals to 13/10, so from here your velocity will be maximum. Okay, so from here, in order to get your velocity to be maximum, you need to differentiate your velocity with respect to time, and you must set it equals to 0. Okay, still remember the turning point concept. So that is the concept that we're going to apply over here. Okay, so we're going to differentiate the velocity with respect to time. Okay, so from here, dv over dt, okay, we're going to set this equals to 0. Okay, so from here you differentiate this equation. Okay, but before that, you expand this bracket inside. So from here, so let me write the complete expansion for the velocity equation, where it is equals to q plus with 3qt minus 5t minus pt square. Okay, so from here you apply this dv over dt such that it is equals to 0. Okay, now you can proceed to differentiate this velocity equation. Okay, so you differentiate this. So from here you get 3q minus 5 minus 2pt, okay, it is equals to 0. Since we know that our t value is equals to 13 over 10, you can substitute this value into this equation over here. So from here, 3q minus 5 minus 2p, okay, so you times with 13 over 10, close bracket, you should be getting equals to 0. Okay, so this 10 you simplify, you get 5. So this negative 2 you simplify, you get is negative 1. Okay, so from here you solve this. So from here you get 3q minus 13 over 5 p is equals to 5. So this negative 5 from the left hand side, I literally move it over to the right hand side, guys. Okay, so from here this will be our equation number 1. So let me label this as equation number 1. Okay, so we still have one more equation left before we can proceed to find our solution. Okay, as for our second information is the acceleration of the particle is negative 7 meter per second square when t is equals to 2. So let me mark this as our second information. Okay, so let me write in the working here, when t is equals to 2, so from here you get your acceleration will be equals to negative 7 meter per second square. Okay, so from here, so to find the acceleration, what you do, you need to differentiate the velocity. Okay, as you can see, we have already differentiated the velocity over here. So from here it will be 3q minus 5 minus 2pt. Okay, so this is our acceleration over here. Okay, basically acceleration is equals to dv over dt, guys. Okay, I hope you understand the concept over here. So from here you can substitute this t equals to 2 and a equals to negative 7 meter per second square into this equation. Okay, so from here negative 7 is equals to 3q minus 5 minus 2p. Okay, and from here you times with 2. Okay, so from here negative 7 will be equals to 3q minus 5 minus 4p. Okay, you move this negative 5 to the left hand side. Okay, so from here you should get 3q minus 4p is equals to negative 2. Basically I interchange the sides over here. Okay, so from here this will be our second equation, guys, where you get 3q minus 4p is equals to negative 2. Let me label this as the equation number 2. Okay, so once you get the equation 1 and equation 2, now you can proceed to solve this using the simultaneous equation method. Okay, so for these two equations we are going to use the elimination method. Okay, so from here we can choose to eliminate the variable q first. So from here, using elimination method, so from here 3q minus 13 over 5p is equals to 5. So this is your equation number 1, and this one 3q minus 4p is equals to negative 2. Okay, so this is your equation number 1 and this is your equation number 2. So these two equations, you minus them. Okay, so from here the q variable will get cancelled off. So from here negative 13 over pi p minus with negative 4p. So from here you get is 7 over 5p Okay, and then it will be equals to, this is for the left hand side. As for the right hand side, it will be 5 minus negative 2. So from here it will be 7. Okay, so you calculate this. So from here you should get your P is equals to 5. So this is your first solution. So let me underline this. Okay, so once you get your P value, now it will be easy for us to get the Q value. You can substitute into either one of these equation. Okay, from here I choose to substitute into the equation number 2. So when P is equals to 5, (3q) minus 4, okay, you times with 5. So from here it will be negative 2. Okay, so from here you calculate this, you get 3q is equals to 18. So from here, negative 4 times with 5 will be negative 20. So this negative 20 from the left hand side, you move it over to the right hand side. So it will be negative 2 plus with 20. So negative 2 plus with 20 you get is 18. Okay, so from here 3q is equals to 18. So to get the q, what you do, 18 you divide with 3. So from here you get your q is equals to 6. Okay, so this is your second solution for the question part A. So let me underline the second solution. Okay, so from here let us proceed our discussion for the question part B now. For the question part B, we are required to find the value of t when the particle reverses its direction, and we need to find the total distance travelled by the particle in the first 4 seconds. Okay, let us find this first, the value of t when the particle reverses its direction. Okay, so one thing you should know, when the particle starts to reverse its direction, the velocity of the particle will be equals to 0. Okay, so let us begin our working for the question part B. Okay, when the direction of the particle is reversed, so from here velocity of the particle will be equals to 0. Okay, let me box this. Okay, so let me write the original velocity equation with the variable p and q. So from here the v will be equals to q plus with, in a bracket, 3q minus 5 close bracket t minus pt square. Since in the question part A we already get the value of p and q, where p is equals to 5 and q equals to 6 respectively, now we can use these two values and substitute into this velocity equation. So from here v will be equals to 6 plus, in a bracket, 3 times with 6 minus 5 close bracket t minus with 5 t square. Okay, so from here v will be equals to 6 plus 13 t minus 5 t square. Okay, so since we get the velocity equation, now we can set this equals to 0. So from here 6 plus 13 t minus 5 t square is equals to 0. Okay, so you move all these variables into the right hand side. So from here 5 t square minus 13 t minus 6 is equals to 0. Okay, so now you perform the factorization. From here you will get 5 t plus 2 and t minus 3 equals to 0. Okay. But then you should know that your time cannot be a negative value. Okay. So from here, since time cannot be negative value, so from here you only can have one possible answer where your t is equals to 3 seconds. Okay. So let me underline the first solution for the question part B. Okay. Once we get the time where the particles start to reverse, now we can proceed to find the distance of the particle travel for the first 4 seconds. Okay. So let us begin our calculation for that. So the first step, what you need to do is you need to find the displacement of the particle. Okay, so how to find the displacement when you only have the velocity equation? No problem guys, you can integrate the velocity equation with respect to time. So from there you should get the displacement. Okay, so from here displacement is equals to integration of velocity with respect to time. So let me box this. Okay, so from here displacement will be equals to, so the integral of, in the bracket, 6 plus with 13 t minus with 5 t square close bracket with respect to dt. Okay, so you perform the integration. So from here you get your displacement s is equals to 6t plus 13 t square over 2 minus 5 t cube over 3 plus c. Okay, from here you need to add an important information. When t is equals to 0, s equals to 0. When t is equals to 0, s equals to 0. Okay, so since you substitute this value into this equation, indirectly your c also becomes 0 as well. So from here your displacement of the particle will be equals to 6t plus 13 t square over 2 minus 5 t cube over 3. Okay, so once we find the displacement, now the next step what we can do is we can start to calculate the displacement for the first 4 seconds. Okay, so let me write that in the working here. Let us begin our calculation starting with 0 second, okay, followed by 1 second, and then 2 second, and then 3 second. At last you'll go for the 4th second. Okay, so from here when t is equals to 0, your displacement will be equals to 0 meter. Okay, basically what you need to do is you need to substitute the t values for the first 4 seconds into this equation, and you must get the respective displacement value. Okay, that is the one I'm listing out over here. Okay, when your t is equals to 1, so from here you get your displacement is equals to 10 5 over 6 meter. Okay, followed by when t is equals to 2, displacement will be equals to 24 2 over 3 meter. Okay, continue with t is equals to 3, so the displacement will be equals to 31 1 over 2 meter. Okay, at last when t is equals to 4, So the displacement will be equals to 21 1 over 3 meter. Okay, for the next step, what we're going to do is we're going to sketch the motion diagram of the particle. Okay, by the way, I've already completed the sketch for the motion diagram of the particle. So let me show it to you now. So this is the sketch. Okay, so let me move it to the top. Okay, so let me move it up. Okay, so this is the complete sketch of the motion diagram of the particle for the first 4 seconds respectively. So from here, what we're going to do is we're going to use this motion diagram to calculate our distance traveled for the first 4 seconds. Okay, so from here, let us start. The distance traveled in the first second, okay, will be equals to modulus of S1 minus with S0, okay, where will be equals to please wait guys, okay, will be equals to modulus 10 5 over 6 meter minus with 0 close modulus, where we'll be getting equals to 10 5 over 6 meter. Okay, followed by distance traveled during the second second, where will be equals to modulus of S2 minus S1 close modulus. Okay, so from here it will be modulus of 24 2 over 3 meter minus 10 5 over 6 meter close modulus. Okay, so you calculate this, you should get your distance traveled for the second will be 13 5 over 6 meter. Okay, continue to calculate the distance traveled during the third second, where will be equals to S3 modulus of S3 minus with S2 close modulus, okay, equals to modulus of 31 1 over 2 meter minus with 24 2 over 3 meter close modulus. So you calculate this, you should get your distance traveled during the third second will be 6 5 over 6 meter. Okay, at last you need to calculate the distance traveled during the fourth second. So from here it will be equals to modulus of S4 minus S3, okay, close modulus, where it will be equals to modulus of 21 1 over 3 meter, okay, minus with 31 1 over 2 meter close modulus. So you calculate this, you should get your distance traveled is equals to 10 1 over 6 meter. Okay, so to calculate the total distance traveled in the first 4 seconds, what you need to do is basically you just have to plus all these 4 together. Okay, so from here your total distance should be equals to 41 2 over 3 meter. So this is your total distance traveled in the first 4 seconds. Okay, so let me underline the second solution for the question part B. Okay, so from here let us proceed our discussion for the question part C now. For the question part C, we are required to find the range of values of t when the particle travels due west. In this question, they also mentioned that take the motion due east as the positive direction. So in this case, the particle is traveling from east to west. Okay, so from here, when your particle is traveling from east, where in this case your east is the positive direction, and it moves to west, where in this case the west is considered the negative direction, your velocity will be less than 0. Okay, so let us begin our working now. For the question part C, for particle travel from east to west, So from here, velocity will be less than 0. Okay, let me box this. Okay, so from here, let me write the velocity equation here, where 6 plus with 13 t minus 5 t square, okay, should be less than 0. Okay, now what you do, you shift this side. Okay, since you have the coefficient of t square is negative value, we need to make sure this coefficient is in positive. Okay, but then you need to be careful, since it's involving an inequality. When you shift the side, you need to shift the inequality sign as well. So from here, when you move these variables from left hand side to the right hand side, so it will become 5t square minus 13t minus 6 should be more than 0. Okay, so from here you perform the factorization, so you get 5t plus 2, okay, and then you get t minus 3 more than 0. Okay, one thing you need to know, the time cannot be a negative value. Since the time cannot be a negative value, so you can only have one possible answer where your t can only be equals to 3, whereas your t cannot be equals to negative 2 over 5. So let me write the full statement here. So from here, your time will be more than 3 seconds. So this is your answer for the question part C. So let me underline the solution. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.